Dynamic memory allocation in C provides two primary functions, malloc and calloc. While both allocate memory at runtime, they have important differences in behavior and usage. The malloc function allocates a block of memory of the specified size in bytes. However, the allocated memory is uninitialized, meaning it contains whatever garbage values were previously stored in those memory locations. Here we see a memory grid representing allocated memory. When malloc allocates memory, each cell contains random garbage values from previous usage. These hexadecimal values represent the unpredictable garbage data that malloc leaves in memory. This uninitialized state can lead to bugs if not handled properly. The calloc function allocates memory for an array of elements. It takes two parameters, the number of elements and the size of each element. Unlike malloc, calloc initializes all allocated bytes to 0. Here we see the same memory grid, but after calloc allocation. Notice how calloc automatically initializes all memory locations to 0, providing a clean, predictable starting state. All memory locations are initialized to 0, making calloc safer and more predictable for applications that require clean memory. Here are the key differences between malloc and calloc. Malloc provides uninitialized memory with a single size parameter and faster allocation, but no overflow protection. Calloc provides zero initialized memory with two parameters, includes overflow protection, but is slightly slower due to the zeroing process. Both malloc and calloc return a void pointer to the allocated memory, or null if allocation fails. It is crucial to always check for null before using the returned pointer to prevent crashes. Finally, remember that both malloc and calloc allocate memory on the heap, which must be manually freed using the free function. Failing to free allocated memory leads to memory leaks, which can cause your program to consume excessive memory over time. When should you choose malloc versus calloc? The decision depends on your specific use case and performance requirements. Let's explore the key factors that should guide your choice. Use calloc when you need the allocated memory to be 0 initialized. This is essential for arrays where all elements should start at 0, or when working with data structures that rely on initial 0 values. Here's what calloc allocated memory looks like. Notice how every byte is guaranteed to be 0, providing a clean, predictable starting state for your data. Use malloc when you plan to immediately overwrite the allocated memory with your own data. Since malloc doesn't 0 initialize memory, it's more efficient when initialization is unnecessary. Malloc allocated memory contains whatever data was previously stored in those memory locations. This unpredictable content is why you should always initialize malloc memory before use. Now let's clear the screen and focus on essential best practices that apply to both malloc and calloc. These practices will help you write robust memory-safe code. Best practice number 1. Always check the return value for null. Both malloc and calloc can fail if there's insufficient memory available, and they'll return null to indicate failure. Best practice number 2. Always pair your malloc or calloc calls with a corresponding free call. This releases the memory back to the system when it's no longer needed. Failing to follow these practices leads to memory leaks. Let me show you what happens when allocated memory is never freed. It accumulates over time and can eventually crash your program. Watch as repeated allocations without corresponding free calls cause memory usage to grow continuously. This is a memory leak in action. Allocated memory that can never be reclaimed. In summary, choose calloc for 0 initialized memory and built-in overflow protection. Choose malloc for better performance when you'll immediately overwrite the data. Always check return values and pair every allocation with free to prevent memory leaks.